Okay, hello everyone. My name is Artur Zygadlo. I'm a senior technical leader at deepsense.ai. Today I have the pleasure of telling you about a project that our team at deepsense.ai recently did in collaboration with our colleagues from Anyscale. The talk will be about an application which allows its users to search for their favorite pieces of clothing using cross-modal image retrieval. I will tell you how we leveraged Ray to make the solution scalable and efficient, and how the Anyscale platform facilitated our development and deployment. This is the agenda of my talk. First, I will introduce you to the topic of cross-modal search. Then I will tell you how we implemented our embedding pipeline using Ray data. Then I will show you our application's architecture and tell you how we do inference using Ray Serve. And of course, there will be a summary slide at the end, and some ideas for future improvements will be mentioned. We will actually start by me showing you how the application looks, and then I will tell you how it works under the hood. So in the world of e-commerce, finding a perfect product, a perfect purchase is often challenging, especially due to the varying quality and level of sophistication of product metadata. Looking for a product based on its description or name alone is often insufficient. And that's where applications such as text-to-image or image-to-image search become valuable. As you can see in our application, the user can specify the description of the desired product with a text prompt, but they can also upload a reference image to which the results should be as similar as possible. Apart from switching between searching by text or image, the user can also select one of the available embedding models, which I will tell you about in a moment. And as you can see on the right side, each of the results is assigned a score, which represents its similarity to the input query. Under the hood, we use an approach called cross-modal search, and in particular, we rely on a model called CLIP. CLIP is an idea that was first introduced by OpenAI in 2021, and it's a model that can take an input. It can be an image or text, and turn it into a vector, and the vector is in a single vector space shared between those two modalities. The model learns to do so by being trained to identify matching pairs of images and their text descriptions within a batch of n such pairs. Having trained such a model, we can take the input query, no matter if it's an image or text, and turn it into a vector that can then be used to search for similar items in previously pre-calculated and populated vector index. So we have actually two indexes, one for images and one for texts, representing the contents of our database. The original CLIP model from OpenAI was trained on general domain data, but it's worth mentioning that such models can also be adapted to specific domains, and there already exist models fine-tuned to remote sensing, biomedical domain, and fashion domain, to name a few. And actually, the fashion CLIP model is what we use in our application, along with the original OpenAI CLIP. All right, now let's move to talking about Ray. Before we develop the application itself, before we move to the inference stage, we need to, as I already mentioned, pre-calculate the vector indexes for storing embedding vectors for texts and images. And that's where we leverage Ray data. The embedding pipeline looks very similar for both modalities. So first there is some data loading step, followed by preprocessing or tokenization, and then there is embedding generation by CLIP, and finally the embeddings are upserted to the vector store. In our case it was Pinecone, and the role of Ray and Ray data in particular in the pipeline is to make the solution scalable and efficient by parallelizing the calculations across batches of images or texts. And the implementation of such a pipeline with Ray data is very simple, very straightforward. First of all, there is an out-of-the-box support for many popular formats, which can be loaded, so the data can be loaded into a Ray dataset object very easily. Next, you can seamlessly move your data between devices, CPUs and GPUs. In our case, we use the GPUs for the embedding calculation, while the rest of the pipeline remained on the CPUs. And you can also apply your custom functions to batches or individual rows in parallel very efficiently with map and map batches functionalities of Ray data. After running such a pipeline twice, you end up with the two indices, one for images, one for texts, populated with the contents, or with the vectors representing the contents of our fashion data set. Now we can move on to the application itself. Here we leverage RayServe to deploy the application. The application itself consists of several components that communicate with each other to perform the calculation of embeddings, cross-modal search, and re-ranking of the results, as well as their visualization. RayServe facilitates serving and scaling the application, but it also introduces out-of-the-box batching to each of the application's components. I already mentioned before that we also utilize the Anyscale platform in the project. One of the functionalities that we took advantage of was the Anyscale services, which helped us deploy and scale the application by utilizing several features such as autoscaling, cluster monitoring, and rolling deployment strategy, to name a few. We also benefited from the Anyscale workspaces, which allowed us to save time and focus more on coding tasks. We didn't really need to worry too much about the Ray cluster setup and other infrastructure-related topics. And last but not least, Anyscale jobs, which are also part of the platform and serve the purpose of running batch workloads in production. This is what we use in the offline embedding generation pipeline that I described before. The Anyscale jobs allow to easily transition from development to production scale environments. Running an Anyscale job is very, very easy. All you need to do is to prepare a configuration file in the YAML format, which can more or less look like the one on the slide. What's also useful is that you can then conveniently track your job in the platform. You can check its status, related logs and metrics there. After telling you about the project, let me also show you the people behind it. As I already mentioned, this was a collaboration between deepsense.ai and Anyscale. On the deepsense.ai side, it was Natalia and Mateusz who did most of the work with a bit of my help. We were also supported by our colleagues from Anyscale, Marwan and Kamil, who made sure that our code follows the Ray best practices and that we fully benefit from the newly introduced Anyscale platform features. Thank you guys for that. And we hope that this was not just a one-time collaboration. We're hoping for many more interesting projects to work on together. Let me conclude the presentation. So I just described the fashion search application, which we built on top of Ray and Anyscale platform. We leveraged Ray data to ensure the efficiency of parallelization in the offline embedding generation pipeline. We also used Pinecone as our vector store. We utilized clip models for cross-modal retrieval. RayServe allowed us to optimize the application's performance and auto-scale it. I haven't mentioned Gradio before, but this is the tool that allowed us to develop an easy-to-modify, extendable, and intuitive user interface. And last but not least, the Anyscale platform with features such as services, jobs, and workspaces. One of the ideas that we were considering for future exploration, for future improvement of the application, was to actually replace or somehow enhance the replace clip or somehow enhance the application with multimodal generative models like Lava. Interestingly, this direction was later explored by our colleagues from Anyscale. I highly recommend their blog, which describes their insights from the experiment. And what I just described is actually also described in more detail in Anyscale blog. This was just a brief overview of our project. More details can be found at Anyscale blog post, which we released in early June. There is also supporting code implementation available at Anyscale GitHub. Feel free to check it out if you're interested in more detail. And I believe that through our collaboration, we actually not only developed a single application, but provided a kind of a practical roadmap for developing similar, efficient, scalable, and intuitive applications powered by Ray. Let me also tell you a few words about my company, deepsense.ai. We are an AI services company. We work with companies from all over the globe. We help them unlock the full potential of AI. We offer both AI guidance and AI implementation services. We've been doing similar things for over 10 years already, and we have a track record of over 200 commercial AI projects. You can see a selection of our clients' logos on the slide. We recently, obviously, mostly focus on Gen AI applications, LLMs, and RAG, but we also do a lot around MLOps, computer vision, predictive analytics, and edge AI solutions. That's all I wanted to share. Thank you for your attention. I hope you found it interesting, and I'll be more than happy to discuss anything that caught your attention later during the event and also after the event. Thank you very much.